quantum numbers are really just codes for an electron's position and energy around an atom, and also the spin of that electron. So this is some series of quantum numbers for this electron. That first number that you would see is the principal quantum number. Really, it just represents the principal energy level that an electron might be in. And then the second number that you see is the angular momentum quantum number. Really, it just represents the sublevel that the electron's in, whether it's S or P or D or F. And then we have the magnetic quantum number. That represents whether the spin might be in the X or Y or Z axis going around the nucleus. So whether it's, if you have the nucleus here, whether an electron might be going in the X or the Y or the Z axis. Finally, we have the electron spin quantum number, which says whether the electron might be going in a clockwise or counterclockwise way around the nucleus. So let's take a look at a couple possibilities, or a couple kind of facts. If you're talking about an electron in an S sublevel, then its angular momentum quantum number is 0. If it's in the P sublevel, then it's 1, D it's 2, F it's 3. That's kind of like a memorized thing. So also, if you have maybe 3 orbitals in a sublevel, then there might be 1, 2, 3 different magnetic quantum numbers. Each of those represents an orbital. If you had only 1 orbital, then you would have only 1 magnetic quantum number. In all cases, the middle one might be the value of 0, and then you kind of get a range. If you have 3 orbitals, then you have -1, 0, and +1 possible magnetic quantum numbers. But if you had, say, 5 orbitals, you'd have -2, -1, 0, +1, +2. 5 possible magnetic quantum numbers. And then finally, MS can have values of +½ or -½ You could say that an upspin, a clockwise spin, might be +½ and a downspin, a counterclockwise spin, might be -½ So why is this the code for this electron? All right. So it is in principal energy level 2, in the 2p, so its n value is 2. It is in a p subshell, so its L value is 1. It is not in the middle, but in the right orbital, and so its ML value is not 0, it's +1. And it's upspin, so it has a MS value of +½ Trying another one. This downspin electron on the right, it's in principal energy level 1. It's in an s orbital, so its L value is 0. And any s subshell has only 1 orbital, its ML value is 0. And it's downspin, so it's got a -½ value for MS, downspin, -½ value, which is an arbitrary determination. Okay, so you're most likely to encounter questions like, what are the possible quantum numbers for an electron in a 3p subshell? So here are some rules. Given an n value for an electron, L values can range from 0 to n-1. So if you had n is equal to 3, then L could range from 0 to 1 to 2, but not up to 3. And then the ML values can range from -L to +L. And ms can be positive half or negative half. So if we're dealing with an electron in the 3p subshell, then it's in principal energy level 3, n is equal to 3, and being in a p subshell, L is equal to 1. So ML can range from negative 1 to positive 1. There are 3 possible orbitals that it might be in. So there's 3 ML values. Any p subshell can hold 3 orbitals. And then finally, the MS is always going to have possibilities of plus half or negative half. Doesn't depend on the n value or the L value or the ML value. Okay. Then you might ask, or might be asked, are these series of quantum numbers possible? So let's say that n were equal to 2. Could L be equal to 2 and then ML be equal to negative 1 and MS be equal to negative half? All right, so if n is equal to 2, then the only possible values for L are between 0 and n minus 1. So the only possible values for L are between 0 and 2 minus 1, or 1. So this is not possible. L can only be equal to 0 or 1 if n is equal to 2. L cannot be up to or past the value of n. Now, kind of moving on to the next one. What if n were equal to 3? Could L be equal to 2? Sure, L can range between 0 and n minus 1. If n is equal to 3, then L could be equal to 0, 1, or 2. Now, if L is equal to 2, could ML be equal to negative 2? Sure. ML can range from negative L to positive L. So, if L is equal to 2, then ML could be negative 2, negative 1, 0, plus 1, or plus 2. This negative 2 is in that range, so this is possible. What about MS? Could that be equal to 1? Nope. MS always needs to be equal to plus half or negative half. Positive or negative spin, counterclockwise or clockwise. Okay? Thanks for watching.